if you were to besides the racism, like what would you describe the Papa John's like? Okay, so they got the stuffed crust.
Like
That's just Pizza Hut, right? They just ripped that off.
upscale Domino's, yeah.
Upscale Domino's.
Upscale might even be generous. Twitch was just showing. It was showing me like the old video for some reason. I was like, "That's weird." Okay, I'm gonna put a cut there. I'll put a clap. All right.
I'm gonna
start the stream.
We need the little clapper thing. What do you call those things?
Are they just called clappers or clickers?
There might be clappers.
Ah. I do not know.
Filmmaking clapper thing. Clapperboard.
Clapperboard.
There you go.
You know,
why did they click that thing before filming a movie?
I like that. I like that they
to synchronize the audio and the video, right?
I thought it was that, and to give you a really nice place to. It was like a place to cut the audio and the video as well. Like you have a loud noise and a visual cue.
Yeah.
To make it easy to see takes.
Yep.
Clever.
What you eating for dinner tonight, Tom?
I just made some gnocchi. Gnocchi. Yeah.
Like, you like formed the gnocchi yourself?
No, I just boiled some Trader Joe's gnocchi.
Okay.
Though I think it's incredibly easy to form the gnocchi yourself.
I've never tried, actually.
I think it's just like potatoes and water and I don't know, like you do something with a fork.
Yeah. Usually I defrost my gnocchi from a bag of frozen. Yeah.
Whoa there, getting fancy.
Yeah.
I like whatever these are shelf stable, which blows my mind, and I love it.
I just got a cast iron pan, the first one I've ever owned, and cooked a bunch of stuff over the weekend.
What was your cast iron like? Were you making cornbread? What'd you do with it?
I did Impossible Burger.
Okay, yeah.
Then I basically made a bunch of like meat substitutes. Right, I made a pulled pork sandwich made with king oyster mushrooms. You ever done that before?
No, that sounds.
So you know what a king oyster mushroom looks like, right?
Yeah.
You shred it up with a fork, and the fibers run like along the length of the stem. So it kind of just shreds up like a shredded chicken or pork.
Oh shit, that's really cool.
And then when you throw it on the cast iron, it kind of chars up. I don't think mushrooms quite get crispy though. I don't think I've ever had a crispy mushroom.
And I've done pulled pork with jackfruit, which also doesn't get crispy in quite the right way.
Okay, yeah.
Ooh.
Yeah, but it's pretty good.
That sounds really good.
Yeah.
Damn. All right. Man, I used to have a cast iron. I got rid of it just because, like, I knew I wasn't cleaning it right or seasoning it right. I was just like, this is too much work. I'm going back to nonstick.
It's a little bit of effort. Even washing it, you feel a little bit nervous ruining it, so you gotta like wash it right away. It takes some special handling.
Mm-hmm. Yeah, you can't scrub it. You can't soap it.
Yeah. Oh hey, it's come up on me without me even realizing it. But a quick scheduling update is that I think I'm out next Monday.
You're out next Monday.
Yeah.
Okay,
well,
cool.
I'm gonna start a 2-week break this Friday. And I'm actually gonna go on a trip to a town called Sea Ranch. Do you know this? It's just south of Mendocino.
Fun.
And I think the dates are like Saturday through Tuesday.
Okay.
Kind of a weird break, but yeah.
Yeah, but I think that's what you get to do when you have 2 weeks off. So.
Yeah, we wanted to, go somewhere, but didn't really want to get on a plane,
Yeah, that's fair.
I know a lot of people that are just like piecing out to Hawaii right now, and I didn't know that was possible. Don't you just have to like quarantine for a while?
Oh, I think you have to quarantine for 2 weeks, but like that could be at your cabana by the beach, right?
Yeah, that's true.
Yeah.
That is true. Yeah.
Yeah, sounds pretty good. That's great. So you're out next Monday the 15th. I think I'm out Monday the 12th. Far in the future. April 12th. Sorry.
April 12th.
April 12th.
Okay.
But I will
Right.
I will decline this on the calendar. So at least we have that marker. Yeah. I'm also like taking a hiking trip up to that same part of the coast. It's going to be great.
Yeah, I realize I've never been further north on the coast than Point Reyes. So this is going to be a bit of a trailblaze for me.
Oh shit. There's some really good stuff up there.
Yeah.
Yeah, if you're up there for a couple days, it's worth driving like the hour north to Liggett and like the Great Redwood Trail,
Okay.
because that's like just some of the coolest shit in California. You can drive your car through a tree. It's worth it. It's like some real California tourism shit.
Yeah, I remember there's like a Sequoia Bridge in Sequoia National Park. Same kind of deal. You
Yeah,
drive your car on the thing.
yeah, that's really rad. All right. It's like 2.5 hours north, so
Okay.
maybe not.
All right.
It's a long day
Well, I'll
trip.
keep it in mind. I actually don't know what I'm going to do when I get up there. I'll be up there. There'll be trees. There's going to be the Pacific Ocean. I'm supposed to leave an hour a day to just stare at the ocean.
Tide pools. Go tide pooling.
Okay. Yeah.
Very, very, very rad. Will definitely kill at least an afternoon for you. Yeah, there's a lot of beaches. It's like nice up there.
Okay. Cool. Cool.
Oh, you're gonna have fun. I have enjoyed that part of the coast a lot. So
Yeah. Yeah. Now, just the way it goes for vacations for me, like I don't even really anticipate them until like 2 days ahead of time, and then I'm like start to look forward to them. You know what I mean?
excellent. And you're off for 2 weeks, but like just 2 weeks.
Yeah,
of
I'm
no
off for
work.
2 weeks, but the trip itself is just the feet, like 3 or 4 days.
Nice.
Yeah, and then I think the rest of the time gonna be hanging around town. I just needed to burn the PTO. Nobody's traveling right now. Nobody's taking any PTO off right now.
You could go and stand outside vaccine clinics waiting for them to throw away some doses.
Uh, that is not what I was planning on doing, but it's not a horrible idea.
It's
either.
not a bad idea.
Yeah.
Like 10 of my friends got vaccinated in Sacramento this weekend. Just doing that, they like a hospital had too many
They
doses.
dumpster dove the
Basically,
vaccine.
yeah. Hospital had too many doses, so like they just went and did it.
That is
Yeah,
weird.
I think it's the weirdness is that as soon as you open the bottle of this stuff, you have to use it. So if anyone cancels an appointment, a dose gets wasted for the day.
Right.
So there's like,
But then that also puts you on the docket for your next dose, right?
yep, but they just do it. They're just like we wasted one less thing today, which means like one less person having to wait for it in the future, and like there's no restrictions on getting wasted doses, which is like
Okay.
it's fine. It's a lot of work. I am 0% interested, which is why I didn't go with them because like I unsubscribed from like the notification thread, the signal thread. I was just like, nah, like this will all be solved in like 2 months. I'm good.
I did sign up to volunteer.
Oh yeah, yeah, we all did though. Like,
Yeah, that is true. Supposedly, well, they just approved the Johnson & Johnson vaccine.
yeah, that one's great.
Yeah, which is just good enough for me. Good enough for everybody. It's only one shot as well.
Yeah, I will 100% get that in my arm and be
Yeah.
totally happy. I'll
Yeah.
be a little sad I won't get the cool like RNA thing. That's the only thing I want is the rad like
Yeah, at
cyberpunk
like
biotech.
negative 70 degrees Celsius or something like that. Super cold.
Well, like how cool is it to get like a DNA injection, right? That's the only thing I'd miss
Well,
out
that's
on.
what a virus is. It's just a bunch of DNA, right?
Yeah, that's a good point.
Yeah.
I think we are in for like 2 or 3 years of getting booster shots for this though. So like
Yeah, variants and that sort of thing.
yeah,
Yeah.
it's I will get my opportunity to get like a cool future tech vaccine at some point. I'm positive.
Yeah. Yeah. Good time to be in the mRNA replication business, right?
It's 3D print a lot of shit. Yeah.
Yeah, apparently the actual I feel like the Moderna vaccine.
Is it not the same
They-
thing? I thought it was the Pfizer. I thought they
Moderna and the AstraZeneca.
Mm-hmm.
AstraZeneca. How would you pronounce that?
I have never heard that word said out loud. All right,
Yeah.
I'm just back. on talking
AstraZeneca
heads.
is what I usually hear, but then I was like, is the Zeneca like Seneca, the Greek philosopher? Also the upstate New York City, right? Seneca Falls. Is that not where like Susan B. Anthony and the suffragettes hung out? I don't know. I'm
Oh, you're
sort
right.
of confused.
Yeah. But
This is just random shit that's
it
like
Sen-
spewing out of my brain
is it
to never
Seneca
be.
Falls? We'll never know.
Yeah, to never be recalled again. It's like tinnitus. It's like that buzzing you hear. Like
Yep.
you hear it, and then you're never going to hear that frequency again.
Oh, that's
That's what
funny.
they say. That's exactly what is coming out of my mouth right now. So the vaccine, at any rate, apparently it took however many years of development, 10, 15 years of developing the technique. But when they decided to like make the coronavirus vaccine, they were like, okay, well, let's look at the structure of the virus. Seems like the spike protein's the thing to attack. And then once they figured out that was it, they just sequence the virus, figure out where the spike protein is, and they literally just like start making the vaccine like in a week.
Right. The thing we're using is what they 3D printed the first week the thing came out. Right. They were just like,
exactly.
They're like, we think this is pretty good. Like,
yeah, exactly.
We modeled it. It's wild.
Yeah. And now we just have to test it, right? And that's basically what the rest of the year was about.
Yep. Yeah. And I assume getting production capacity or something.
Sure.
But also they're using it for malaria now. Like it's really cool. It's super neat that works.
Malaria, really?
Yeah, they realized that like they could RNA print a very similar thing for a malaria vaccine. So like now we have that.
Is malaria a virus? What?
Malaria is a virus, and it's definitely an endemic.
It's not caused by a virus or
it's a
bacteria.
parasite. It's a parasite.
It's a parasite. Yes.
But we might.
What a bastard!
Soon have a vaccine for that and eliminate one more genocide, one more species on the planet, but for a good cause.
Malaria is a bastard.
Yeah, it seems real bad.
Yeah.
Future tech, really cool though.
Yeah.
Oh, alrighty. How about that instance rendering?
Yeah, let's talk about instance rendering. Although I kind of want to fix the Doghead.
Let's fix the Doghead. Because
like, the Doghead doesn't turn while we move.
That looks really weird. And that must be... It's not that we're not sending mouse... maybe the move event is actually eating that. Maybe we forgot to put the orientation in there when that event's going through.
Interesting. I think we probably have it just an early out somewhere. Where does the head actually move?
That's the dog. I think it's in the shooter system. That's the head. So that's pretty early. But that's a pretty early out at the top of that too, huh?
This is fine. I think I somewhat recall. Well, okay. So here's one interesting thing that I had to do. I refactored this. When did I do this? I can't. It was before last time. What happened is I moved everything. Like when you shoot. Oh, come on. I hate Visual Studio so much when it does this.
There is a way to turn that off.
Is there?
I turned it off on mine. It's much much
Do you know what it's called?
Search preferences for preview.
I really want to do it right now.
Yeah.
No.
Yeah.
For this one?
Oh no, shit! It's not that. I'm gonna find you keep doing so. I'm gonna Google because I've done this.
VS Code, go to definition, disable preview. There's peak definition.
It's peak.
It's never what I want.
Oops, scroll up one bit. Oh, I saw it.
It controls the behavior of the go-to definition command when multiple targets. No, that's not what I want. There's been like feature creep here.
So when you go back to your go back to the systems file, I think the problem is there's multiple definitions. It was in systems TS or systems index, whatever.
Simulate. Yeah.
So 2 definitions. What is the other one in the index? I think it's because we are renaming stuff. Actually, I think if you take all the as's out, that no longer happens. But if you go back to settings when there's multiple definitions, because this is what you want to change for settings. The one above this.
Go to?
Yeah.
Oh, this one.
Yeah, so just go to, and then it will dive into the index file, and you can command click onto the next one.
Wonderful. Okay.
Yeah. Which is like totally fine.
That's fine. Yeah, that's totally fine. Yeah, I don't know what to do with that pop-up there. I'm just like, how do I get out of this?
It's nonsense.
Yeah. I can't really copy and paste out of it. Like, there's a lot that's bad.
No, and it's in that weird space where it's like clearly a popover, but like not any native UI element. So like you're just screwed.
Yeah. So what happened is I made that event system, that frame event system. We talked about this last time a little bit. And what it does is like when you encounter an event that you want side effects to trigger from,
you
just push them in, and then some later system will take care of it.
I love it. Okay.
But what that means is that the tank mover, which used to be the very first thing that we ran, is now running after a lot of these things.
Oh, interesting.
Right. So we used to move before we shot, and now that is not the case. Right. And also the attack system gets resolved before we move. Kind of an interesting chicken and egg sort of thing.
You know
so
what? I bet that's it, because we resolve the attack system, which should turn the head, and then we reorient the Sheba in the direction of travel. And do we clear out? Well, that shouldn't clear out the subsequent transform, though. That should be totally fine.
So let's check it out.
It should be wrong, actually, I think.
The shooter system, we rotate the head somewhere right here, right?
It's in the attack system. Oh, sorry, no, it's in shooter, yep.
And
so we do it off of the transform orientation, at least. On line 61.
Yeah. And the transform is the dog's transform, right?
Yeah.
And it's going to be the previous, because we're going to be calculating this based on the previous position of the dog. That's okay. Whatever. We're a frame off. It's not a big deal, right? Previously, this was like the updated position of the dog.
Right.
Now it's the one before, right? And it doesn't affect firing, so I think and where we're not moving, it's fine. You know, you can see a little bit of lag, but the lag actually is introduced from our input lag, right? Our input delay.
Why does this work when you're not firing, by the way?
Why does it work when I'm not firing?
Well, just because
or when I'm not moving.
When you're not firing, because this comes after a early return in this function. God, the knockback is great, or the kick.
Oh, the attack message actually happens every frame as long as there's a mouse position.
Oh, that's an attack. Okay, great.
Yeah, attack is not a great name for that. I think we should call it something else.
Cool.
It's basically just what the mouse is doing. So if it works, I feel like what about moving would cause this to not take effect? Right. I think that's the question we're trying to ask here.
Yeah. Does anything else touch?
Because I can
still
shoot.
Yeah.
Then I get shot by the turrets, those bastards. You're talking about Sheba head?
Yeah, do we use that anywhere else if we like reset it on... Nope. Damn.
Yeah.
Oh, but we push that into the entity model modifiers array. Do we just write a fresh one in the tank mover and drop this? Like, line 55 maintains it, but do we toss it out?
Do we clobber it somehow? You're talking about this?
Boom. We do indeed.
Oh, I see. We don't merge it with the previous modifiers. Is that right?
Yeah, exactly.
Okay. So we need to do this, right?
Yeah, and... Yep. That's very interesting. Whoa.
That's weird. My, oh, you know what it is?
It's Vim, isn't it?
It's Vim. Vim select. Mouse selection, start visual mode. Yes, that's what I want. So now, if I highlight this, wait. Oh, come on. This is horrible. I'm just going to turn it off. I think I'm gradually not, it's not working out for me, I think. The Vim thing.
I mean, as every good Vim experiment ends.
Yeah. I'm going to disable it for now, and then we will potentially come back to it later if I'm feeling saucy. There's just too many things that are like slightly weird about it.
Yeah. So this is actually just a good bug fix too, because really this should not have collaborated the thing. If we'd done any other modifier at all, it would have been wrong.
Yeah, I agree. So that was it.
Hey.
All right.
Dog's head is popping off.
Okay, great.
Can't believe how silly that is. Oh boy.
We've added a lot of features to the game since we've had a dog, you know.
Oh yeah.
I wonder if the tank feels any better. But let's not deal with it.
Oh, I mean the tank does work better, but you know, who cares?
Oh, and this is going to be on my branch that I'm currently on. What do you usually do about this? Whatever, we'll just keep going. Okay. Speaking of the branch, I do want to talk about it a little bit.
Mm-hmm.
One of the things that happened this weekend upstream is I changed. Let's just take a look at the shader real quick. I changed what the attributes look like and what the uniforms look like. I basically adopted a common name scheme for the uniforms and attributes. I did not figure anything out for outputs from the vertex shader into the fragment shader.
Okay.
I yet to figure out what the name for that kind of thing is. Is it varying? I don't really know. But basically all of our uniform, we're basically using what do you call this, like Hungarian notation?
Yeah.
You kind of like mark the type. I feel a little bit weird about that, but at the same time, we're in a situation where there are attributes that are called transform or like model to world, and then there are uniforms that are called that as well. And I was like, maybe Hungarian notation in this case makes a little bit of sense, right? Because we were talking about like instancing our transforms, right? And if we do that, then it's an attribute. So the model to world matrix is like an attribute. But there's also a model to world uniform, and we want all of this, like the namespace is shared across all of our different shaders, right? We kind of like have a common name scheme for all of these.
That makes sense.
So that's one modification. The other modification is I got rid of our layout system, where we were basically positioning our attributes using a layout keyword. I think it was like layout location equals 0, something like that. But instead, I actually had like a variable substitution where I was doing like shader attribute dot whatever. I thought it was a little bit awkward that I was doing kind of a string substitution that way. So what I did instead is when we load a shader, oh, that's right here. That's convenient. When we load a shader, we do a loop over all of the known shader attributes. So this is convention defined by our game. Oh, wait, I need to add a quick hotkey.
F12.
Yeah, it's pretty hard, right? To type F12 on a Mac keyboard. File open recent. That's something I've done never. Remove key binding. And in quick open. Yeah, no.
Nice. Okay. There you go. So you're just going to add your Vim shortcuts little by little to just this.
Oh, I mean, this isn't a Vim shortcut. This is actually my pre-Vim shortcut, because Control R normally is to redo, like undo and redo in Vim.
Oh, fair.
Yeah. The reason why it wasn't set is because I was using that for redo in Vim. So we have this enum called shader attrib that basically defines the shader positions for all of our conventional attributes.
Nice.
We have position, normal. This is actually not new. I did add these, which are new. And these are instanced attributes. We have the translation, rotation, scale. We're not using these currently in the particletoy, but I intend for it eventually to replace the transform.
I assume we will, yeah.
And then there's a color per instance, right? And then I made a note here that like this transform occupies actually 4 slots. So it's 8, 9, 10, and 11.
Cool.
Right. Okay. So when we look at the renderer, what this is doing is just like, I'm going to go over every attribute that we've defined. And then this is a TypeScript thing. Shader attrib as a runtime value. Have you seen this? As a runtime value, it is a key value object that contains all of. Let's see if I can find this. It contains like mappings between, like reverse mappings between the number and the name. So the name is actually available as a string at runtime.
Oh, interesting.
Yeah, I think we can actually. How's this going to compile down? Yeah. So it creates this like rather confusing looking piece of code that says the string position maps to the number 0, but the number 0, which is what this whole evaluate thing, also maps to the string position.
What?
Right?
That's valid JavaScript?
I mean, the equals just it is an expression. Yeah, it's kind of shitty, but it allows you to do like x equals y equals z, right? Because some psychopaths like doing that, right?
Okay.
I mean, it also lets you do if x equals true, which is a classic bungle, right? Like,
does it let you do that with assignment? I thought you couldn't do that in JS. Maybe it's better that I didn't know that I could do that.
Yeah.
Oh, sorry, that's assignment. You can't do a definition for the scope of the f block right there, can you? Does that work?
Yeah, the let doesn't.
Cool.
Doesn't parse there.
Great.
Yeah.
Great. Then never mind. Of course you can do assignment. I was thinking you were doing definition as well.
Okay. Yeah. No. So because it does like reverse and forward mappings.
Weird.
I need to make sure that I only care about the values that are numbers. Right. I just want 0 through 8. Basically, what I really want to iterate over in this particular situation is just 0, 1, 2, 3, 4, 5, 6, 7, 8. I made this other function here that basically takes that number, that integer, and returns the conventional string value that will show up in the shader source code.
Nice.
Right. So there's this handy function here in the WebGL2 API called bind attribute location. You take an unlinked program. So this happens immediately after I've just created the shader program.
Whoa.
And I take the integer number, I look up the string value that it maps to. And what it does is it says, anytime you encounter the string a position, that's actually the 0th location.
That's cool.
I don't care what order you declared them in the shader, right? Like, and that's the really important thing that we're trying to get around here, is that we might not use every attribute that we're using across the engine in every single shader, and we might not order them the correct way, but this bind attribute location makes sure that they're dealt with consistently. And so therefore we can use this enum in the rest of our like GLTF parsing and that kind of thing to deterministically say that the positions of the verts are always attribute 0, the normals are always attribute 1. And the shaders can be kind of written however they want. As long as they obey our naming convention for the attributes, everything's going to kind of line up
That's awesome.
nicely. Yeah.
Oh, I like that.
Yeah. Yeah, before I was interpolating these values into the shader definition using that layout keyword. And it was a little bit awkward. Okay, so that's kind of the most important change that I think is probably merged to master already.
Nice.
Or merged to main, as it were. Do you hear GitHub? I think GitLab actually changed their default branch to.
I think GitHub too.
Main.
I just expect things to be main now. I'm like super accustomed to it. When a repo has master, I get really confused.
I'm still in the headspace of kind of like transitioning. So because a lot of the repos that I work with right now are still master.
That makes sense. Yeah, it's until work like fully cuts over, it's impossible to remember.
Yeah, it's a non-trivial change to make when there's a lot of like CI and that kind of thing built around the repo. Yeah. Okay. And then because you can't, I don't know why like GLSL doesn't let you do the same thing with uniforms. You'd think in principle that like it'd be the same kind of thing. But that's not the way the API is designed. And so
Damn it.
uniforms are handled like I haven't changed the way they would do with uniforms. Okay. I just changed their conventional names.
Cool.
All right. So what we are going for now that we fixed the head moving around is I was thinking today we could start on the path to making a particle emitter system, right?
Heck yeah.
But in order to do that, we need to get our renderer to support particles.
That is true.
Or in particular, to support instance
rendering, yeah.
Instance rendering, yeah. So I started down that path, and what you are about to see is not going to surprise you.
I can't wait.
I like how it was like Papa John's was a suggestion. Did you hear about that guy? He's like, I spent the last 2 years trying to stop saying the N-word.
Dude, the Papa John's guy is like, it's not like I ever thought he was a good guy, but like he's really gone out of his way to be like kind of a dipshit.
Yeah, was he not removed from his company? Didn't they like divest themselves of his body?
Oh, he's gone. Yeah, he's got to be gone.
Yeah. But yeah, like, can you imagine?
I literally can't. Like, I cannot
being
imagine what
so
rich racist life is like.
Suffused with casual racism that like
that's where it's really
like you
weird.
say that word so much. It's like trying to edit the word or like out of your everyday speech, because people do it, right? There are people that, especially in our line of activity now, like if you're a streamer or whatever, probably, or you're a podcaster, probably you get really good at like not having these, what do you call these, like little particles that we throw into our speech, right?
I wonder if good podcasts are just well edited.
I think they do that as well.
Yeah,
they definitely do that.
Because I think there's like and filters that you can apply.
Yes,
you can machine learn your way out of this problem, but not that problem.
Well, you'd think Papa John. I'm just gonna call him that.
Is his name actually John? Is he John?
I think his name is John. Okay. I think Papa John actually does refer to him, or he's a junior and it refers to his patriarchal lineage or whatever. You know, like this is a guy who's like so accustomed to using the N-word that I think it was actually was he not trying to humble brag? He's like, I've been really working at this problem, right?
That's yeah, you've humble bragged up the wrong tree, sir. Something has gone wrong for you.
Look, I'm not a racist. I've been trying really hard to edit the N-word out of my. I spent the last 2 years really working at it.
Oh.
Down 10%.
Oh Lord. Yeah, I mean,
sometimes in my moments of weakness, I have a cheat night, and I really lean into it.
Cheat night. Order a Papa John's and just go to town. Yeah. No thanks.
Yeah.
Yeah. God, what a weirdo.
Yeah.
All of that for like mediocre pizza too. Why is he that guy?
I don't think I've ever had a Papa John's pizza. It looks good.
It's every pizza commercial looks good.
It's true. Every pizza does look good to me. Yeah.
Well, and the pizza you see in the commercial is not the pizza you get delivered to you. That is
Papa John. What is their thing? Is that they serve you like the partially baked pizza? Is that the idea?
Oh, I don't think so. That sounds great.
All right, we're gonna go to Papa John's.
I mean, Google suggested it.
Yeah. Hey, there's a Papa John's in Berkeley.
High class.
Yeah. Shattuck Avenue. It's like not super far from where.
No, it's right next to the Starbucks.
I didn't even know where the Starbucks is.
Right next to the Papa John's. Obviously.
You know what? It's in that drag that I try to avoid. Do you know what I'm talking about? Like the downtown drag of Berkeley. It's a little too close to campus.
Yeah, it's all fast food and kind of so-so places.
So what is Papa John's pizza brand? Like, if you were to besides the racism, like what would you describe the Papa John's like? Okay, so they got the stuffed crust.
Like,
that's just Pizza Hut, right? They just ripped that off.
Upscale Domino's, yeah.
Upscale Domino's.
Upscale might even be generous, frankly.
Yeah, I mean, I will totally eat Domino's pizza. Right?
So will I. But
yeah,
but I also would not call it wonderful pizza.
Handcrafted specialties.
Yeah, see what their handcrafts. Yeah. I mean, if they're gonna sponsor this episode of the stream,
is that like a Hawaiian there? There's like some yellow stuff, pepperoncinis. Yeah, this does look like a.
That's disgusting looking. Yeah.
I mean, I would totally eat that if you put it in front of me. But yeah, I know what you're saying.
I can like viscerally taste what that cheese pizza looks like.
Yes, I know what you mean. I know what you mean. Okay.
Yeah, that's been served to me at too many bad pizza parties.
Yeah, just looking at the pizza, I kind of have a sense of what they're all about. But so how do they compete? Like, there's just so many different pizzas. Do people must like crave the Papa John's taste, right?
I mean, how do we have Burger King and McDonald's, right? I really don't understand it.
Yeah, there's enough differentiation between the products though. But like pizza though, it feels like it's just harder to tell.
Yeah.
There must be just people who really crave the Papa John's.
It's weird. I mean, we got Little Caesars. I feel like there's a million shitty pizza chains.
Yeah. I really like Little Caesars.
Little Caesars is pretty good.
What we get is the, you know how like Detroit style is popular now?
What is Detroit style?
Yeah.
I do not know how that is popular right now.
It's for some reason these last couple of years, it's just like now Pizza Hut, like, when Pizza Hut jumps on the train, you know that it's
over. Yeah,
it's a little bit of whatever. So it's kind of square looking. Like
okay,
this.
Yeah, sure.
And it's cut into kind of. It looks a little bit like a Sicilian. You know what I mean?
Mm-hmm. Yeah, I remember someone had Sicilian pizza. Maybe it was Pizza Hut Sicilian when I was a kid, but also like I had some of that in Italy and it was great.
Yeah, but the when you get a deep dish from Little Caesars, it's exactly this, and in fact, it kind of comes in this exact form factor.
Nice.
And it's probably been like that since time immemorial. I know that because when I first ordered Little Caesars in recent memories, because Bunny wanted to get it, and she's like, "Let's get the deep dish." And she's like, "This is what I like."
Fascinating.
And you can get a deep dish pie from Little Caesars for like $10, and it's like probably 2 meals for 2 people. That's like 4 servings of pizza.
But she was already aware that this thing existed.
She was already aware that it existed. Okay. Yeah, and it's good. It's like just chock full of butter and melted cheese. It's really doesn't. I'm uncomplicated. It really doesn't.
Now, see, I'm excited to see Square Pie Guys down in San Francisco because someday, when I can go eat pizza outside again, I'm gonna go get a square pie. That's gonna be great.
Okay. Have you heard of this before?
No, you just got me excited about square pies now.
Oh, okay. Yeah. Doesn't San Francisco seem so far right now?
Impossibly far. And yet, it's probably where I'm going to have to go get a vaccine sometime soon.
Oh, okay.
I assume we're going over there. I don't know. Maybe Oakland will get their shit together, but...
Is it hard to get a vaccine? My partner got one in Berkeley.
Really? Oh, yeah. That's great.
Yep.
Then maybe
my mom got her vaccine in Contra Costa County, so...
Oh, shit.
Yeah,
maybe it's not hard. Maybe I just want it.
Maybe you're just actually not.
Maybe you're not.
You haven't qualified. Let me apply Occam's Razor to this conversation right now. I think perhaps maybe you're not allowed to get the vaccine. That's why you haven't gotten it.
They forgot to tell me, but I'm not allowed.
Okay. Hey, I don't want to. Maybe you are allowed. I don't want to jump to conclusions here. Maybe you've got something going on, right?
That's funny.
All right, so this is the particle toy. First of all, it's called render toy. Gosh, amateur. I gotta. Jesus.
I wasn't gonna say anything.
Particle index dot.
Boom.
Index.tsx.
That looks
Isn't it called main.tsx? Oh, this is the particle tool. That's the old particle.
There's an old one. Delete it. It's gone. It didn't do anything.
No, we're going to keep it around. There's probably some techniques we can borrow.
We'll see.
All right, that's fixed. Look at that auto reload, man. We have the best developer experience ever.
It's really good.
It's really good.
Oh man, I've worked for some companies that have much worse developer experience than we do. And so have you, I'm sure. Yeah.
It does help that we only have like 5,000 lines of code and 2 people.
You know what? Yeah, you're right.
So the particle toy is broken, Dom. I'm gonna confess to you that it's broken.
I understand. Sometimes you gotta break some eggs.
Okay. All right. So general interface though. Load particle mesh.
Mm-hmm.
I sort of assume that we could potentially have different meshes, different mesh primitives for particles. So I gave it a name. Like you can load, like just the way that our models are. Like we have dogs, we have tanks, right? So it remains to be seen whether or not we're gonna need more than one of these things, right? Because it's instanced, and theoretically you could do an instance render with all of your particles in one go, right?
Right.
If they were all the same shape, if we weren't doing like
which I
textures,
I think we should probably lean towards. Like that seems pretty reasonable for like our first game engine.
Yeah. Baby's baby's first game engine.
Yeah, exactly.
Indeed. And then you say max instances because, and I'm talking out loud right now, but none of this is set in stone.
Sure.
The API still is sort of floating around in my head. But the reason why you tell it how many instances you want is that this isn't like the buffers haven't been created yet. GL buffers, and the max instances will basically inform us how large to make our buffers.
Gotcha. Okay.
Because we need large buffers for the positions, we need large buffers for, you get what I'm saying.
Yep.
And then there is a render particles.
Oh, ESK is in the chat. Hey, dude, how's it going?
Hey, ESK. It's good to see you, man.
Yeah.
Or, I don't want to presume your gender, actually.
Yeah, actually, yeah, good point. How you doing?
Yes.
Oh, they said they love that every platform native font family that we've got in Index.
Oh, yeah. Wait.
The other Index.
I should have deleted it.
You're
right. You're absolutely
I know.
right. Yeah, I should have just deleted it.
That really is every system.
Yeah. What is Cantarell?
A really delicious mushroom.
Chanterelles. It's the GNOME font.
Oh wow! Okay.
I aspire one day to be a Linux user. This font just screams like bad UI to me. I don't know what it is. I just have that instinct.
You associate with Linux instinctively.
I associate it with and there's an Ubuntu font. What is Oxygen? Do you know what Oxygen is?
No, I haven't seen some of these.
Ubuntu.
They say you've got Apple, Windows, Android, KDE, Ubuntu, and GNOME. Could be KDE or GNOME for
Oxygen is KDE. Yeah. Oxygen font. And ESK has the fonts down.
Seriously, right?
Yeah. KDE, yeah.
Damn.
And this Android, Goe UI.
That must be GNOME.
It is Microsoft.
Oh, Microsoft, yeah.
I'm pronouncing that correctly, Segoe. That's how I would pronounce it in Seago. All right.
Not what I expected.
Yeah. Okay, so this is just like the new sans serif Microsoft font. Cool. Well, I'm glad we were inadvertently very demographic.
Yeah.
Right? We're probably leaving some people out, but I think this is 90% of use cases, 90% of the time.
We must have copy pasted that from somewhere.
I don't know where it came from. And then of course, lowly sans serif.
Yep.
Is that an actual canonical font?
Yeah.
Or is that just whatever your system decides it is?
I'm sorry, it's a canonical HTML or it's canonical CSS property where your system just picks one.
Oh, okay. So what would a modern Mac system choose? Would it choose San Francisco?
You'd think it would, but I bet it picks Helvetica.
Yeah. Okay. And Arial didn't make it in here. Distinguished Arial, sadly.
I mean, you can just replace the entire thing with Arial and call it a day.
It's true. Let's do it.
Wow.
No, you threaten. You say these things, and then you forget who you're talking to, right?
What is shitposting but for code?
I think it's Jeff and Dominic again. Okay, so this is the rendering interface for our particles, right?
Mm-hmm.
And what you do is you name the mesh
Mm-hmm.
or particle model that you loaded with load particles. Maybe this should be called render particle mesh for some symmetry. And you pass it in a mapping of the attribute, the instance attribute you actually want to update, and a numeric array, which is just literally the buffer, like a float32 array filled with data. And then you tell it how many of those things you want to draw, right?
Nice.
Yeah. So it grabs the mesh, which has already been pre-allocated, binds the VAO for all the stuff you want to overwrite. We're going to loop over that. Got the key is the attribute index.
Mm-hmm.
The data is your buffer full of stuff. We're going to grab the GL buffer. So this new there is a mesh object that is stored in a member variable on the renderer called particle meshes that is not the same thing as models. Eventually, we could maybe potentially merge those together, but because they have different data structures, I kept them separate for now. And they actually remember the buffer objects, whereas our models just have the VAOs. Because we never needed to refer to the buffers ever again after we created them. Does that make sense?
Yeah. Okay.
But as you recall, to actually update the data, we need to do this monstrosity. So we actually have to remember what the buffer was, right?
Yeah.
And then call subdata on that, right?
Mm-hmm.
Then we call draw arrays instanced. I believe there actually is a there's a draw elements instance that I missed, and this will allow you to use an index buffer as well.
Ah, that's cool.
Not sure how useful the index buffer is in particles.
Not for this, no. But if we wanted to do tanks, that'd be helpful.
Yes, if we wanted to instance tanks, anytime you have reuse of a vertex, the indexing helps, right?
Nice.
Yeah. Okay. Yes. So we draw it. We say the mesh knows what primitive it is. This is always like a triangle, right? I don't think there's any other lines you can do.
And we have some, but yeah.
Offset into. What does 0 mean? It is the first. I'm struggling to remember what that number actually means.
Well, I feel like we could probably draw 0 to 10 with 0 and count.
Yeah.
If we want to draw subsets of our data set, we could do it with that, right? That's.
Yeah, I think it's like if each thing you're trying to draw is maybe like actually less than the data that's defined in the attributes, you can define a range here.
Mm-hmm. Or sorry, I mean it's 0 to instances though, right? Like we could render half of our particles by.
Oh, that's this one.
Here.
Yeah. This one here is basically how many times we want to repeat this thing, or rather this thing.
Oh, so the 0 is the offset into the data. Okay, yeah, sure, that makes sense.
Yeah. Okay, so that seems like relatively okay so far. I think that makes sense, right?
Mm-hmm.
It's going to be a little bit interesting figuring out like how to do this efficiently.
Yeah.
Because okay, let's take your idea of like every particle emitter actually ends up just being one draw call, like all of them together, like get kind of glommed together, and it's just one draw call.
Mm-hmm.
It almost becomes like a memory allocation problem, where you want to make sure that if a particular particle emitter doesn't get updated, you don't have to make sure. You just want to like avoid overwriting data if you don't have to, right? So, like, let's say you have like one particle emitter that has 20 particles, and you have another particle emitter that has, if particle emitters A, B, and C, and particle emitter A has 10 particles, particle emitter B has 20, and particle, or let's say 5, actually 10, 5, and 10. Let's say that's A, B, and C.
Okay.
And then particle emitter B finishes, but particle emitter A and particle emitter C are still going. How do you update the data so that particle emitter A and B, or sorry, emitter A, should I just actually write this out and not like make us imagine what's going on?
Let's do it.
Yeah. We have emitter A, B, and C, and their counts are 10, 5, and 10. Right? This is quickly going to remind you of like your machine structures class. Because what happens if B goes away?
Right.
I mean, it's not the worst thing in the world, because one thing we could do is like we could just say for each active emitter, for each property in emitter, current emitter, write property data into relevant buffer. And this happens every frame. So I think what that will mean is that you have to basically write 25 particles worth of data every frame, right? And maybe that's not the worst thing in the world.
What's the world where we don't have to write 25 particles every frame? You're saying
it's where the properties don't update, right? Like, because not all of the properties will update at all times, but I'm not sure if there's a super easy way to optimize over that.
Gotcha. Yeah.
And it's actually more interesting when we talk about, let's say like particle A is red, and B is orange, and C is green. If we were super optimized about it, we'd write these colors once when the particles spawned, and then we wouldn't have to overwrite the colors until the emitters went away. However, if B goes away, right? If B ends up going away and we end up only writing A and C, then we have to copy the colors of C over the pre-existing colors, because like the 11th to the 15th particle had the old colors, right?
Yeah.
Interesting. This is a little bit like a memory allocation problem, right? But if we did this algorithm down here that was like super simple-minded, it doesn't matter, because we'd just be writing the maximum every frame.
And I guess like after an emitter is, when it becomes inactive, it's just no longer in there. We end up writing less. That kind of makes sense.
It does. So, I mean, I think what that means, though, is that for our particle system, we're going to have to basically overwrite all of the particle attribute data every single frame.
Every frame. I feel like it worries me.
Which may be fine. I don't know.
Overwriting, like having instance color get overwritten a bunch, sort of worries me, because if we have 1,000 particles and they're all red, writing 1,000 reds feels like both a allocation issue and sort of a GPU issue.
Yeah. Now, let me complicate that a little bit, because if we have particles that are both moving and rotating at the same time, you'd be updating the translation and rotation every frame, right? And you'd be doing it for all 1,000 of them, right? So is it prohibitively expensive for us to add in the color,
to just
or the scale for that matter? Yeah.
That's a great question. Let's try it that way then.
Yeah. So another option.
Wait, sorry. Back to the that definition. will we also, do we need a transform along with translate, rotate, and scale, or are we
No,
going to,
this was just me
that's maintaining
trying to get it
compatibility.
working,
Yeah, okay.
and then we're gonna cut over to
Because
this.
we're going to do our matrix math in the GPU with that. That's great.
We have to write stuff in
Yep.
the shader, and I didn't know how to do that yet.
Cool.
Right, we're
Cool,
gonna have
cool,
to like literally write a quaternion rotation thing here,
Delightful.
which does not look particularly fun.
No, but we can take inspiration from that cool Twitter account that tweets tweet length shaders.
Oh, did I just download the zip file? What I really wanted to do is go to the like how do you rotate something? Is it if we wanted to rotate
We've been
the matrix?
Yeah, we've been doing. I mean, we have been.
Do you convert it to a matrix first?
We've been doing. There was a from rotation in the matrix
yeah.
helper that we've been using in format 4. Yeah. So we haven't even touched the quaternions, but I assume it probably.
I guess there's a from translation wrote. There's
That's
like there's a combined one in here,
Yeah.
right? Is it called from something? From values, from scaling, from rotation, translation, scale, origin.
There you go.
Wow. Yeah, so we basically just have to bake this into a shader. Piece of cake.
I mean, it's
It's not too bad, right? We can
not
copy
the
it
worst,
over.
yeah.
It's not the worst. So I wanted to avoid doing that. So, okay, let's maybe press forward a little bit. So I think for now, like the simple-minded thing is to just say for every particle property, every single frame, we're going to just write over the existing data.
cool. Yeah.
And that solves any kind of like fragmentation problem that we have to deal with, right? Because otherwise we'd have to deal with like, okay, now we have a gap somewhere and we have to like intelligently figure out like which things in the gap need to get overwritten and which ones don't. And that sounds kind of horrible.
Yeah, and I think a lot of our optimization will come from doing as little, like we're going to update as few values as possible in the particle emitter system, because as long as we don't like overwrite color in JavaScript in a way that doesn't need to be, I think we're fine.
Yeah. Another alternative would be to create multiple particle meshes per particle emitter, like, one per particle emitter. And so if a particle emitter dies and goes away, then you actually deallocate the GL buffer. But the problem with that is now you have multiple draw calls, right? You have one draw call per VAO or one draw call per emitter.
Per emitter, yeah.
Yeah.
Let's try the combined way first, though. I
stick with copying. Yeah.
Yeah, I think if we're like, this is super slow and we have to switch to one call per emitter, it's probably going to be fine.
I'm into it. Oh, and I just had an idea, actually.
Yeah.
It's perverse. I think.
Oh, good. My favorite kind.
Dominic Durati enjoys perversity. That's what's going to be in the headlines tomorrow morning.
I like that. Yeah, you were taken aback, and I was like, all right, well, there's the clip for this video. Clip it on Twitch. We'll do it.
We are going to have basically these 4 properties, and we're going to have to do some math on them. Right. What if their basic storage was all contiguous, so that like the stuff that we're doing the physics on, like moving the translation, is like a window over a giant float 32 array, right?
Whoa.
So we're basically updating the values in place so that our when we simulate the particles, we don't have to do an additional copy into a buffer that then goes to it doesn't have to go into this thing, right? We don't have to like copy any data into this numeric array because it's already there, right?
That's clever. Yeah.
So when we have so the way that we don't have a particle system yet, so maybe we should just sketch one right now. Oh look, we've got a particle emitter. Let's do a particle system.ts. It's a little bit confusing because this is not a system qua system in the way that our simulation has systems, right?
Yeah, not quite.
Should it be?
Why did we did it outside of it for the 2D system as well, and why was that the case? I think it was so that we could not resimulate, for one thing.
Yeah, there's a sort of implicit semantic over our simulation where the word system means the game simulation that is shared between the client and the server, and everything else is kind of like superficial fluff, you know, like
I think yeah, it's sort of, though to be fair, we did put like the UI systems in the simulate loop when they were turned on, and maybe that was an interesting mistake.
Player input is a system as well, but that's also not that. I think player input is strictly outside the game simulation. It is like
and
external stuff that influences
does
it.
That
right?
run on resimulation? No.
It does not run in Resim.
Okay.
No. I mean, the thing is that the system, the absolute technical definition of it is a piece of code that lives in the systems folder.
Yeah,
right?
That's fair. That's fair.
That's the most scientific thing. And then we have a simulate function that actually enumerates the things that are actually run during the shared game simulation, right?
Yep.
Yeah. This is a simulation in the sense of we are all living in the simulation, right?
Well, yeah. In that case, I think putting it in the systems folder is not actually the worst, because it is one.
The other distinction is that this particle system is going to maintain state.
Oh, yeah. Okay, never mind.
Yep. But why don't we just call it the particle system for now, and then we'll figure out what to do. The point that I was trying to make is that we will have and this is like contiguous array of vec3s. And colors, right? And if you think about it, when we update our when we call this render particles thing, all we're really doing is like just passing references to these arrays into this. And I think what we'll want to do here is, well, it gets a little bit complicated because this is actually encompassing multiple emitters worth of particles, right? We'll come back to this. Let's get particletoy working again.
Okay.
Now, fascinatingly, I don't really know why it's broken.
I was gonna say it's broken because we're using the normal renderer now, right? Instead of our.
Yeah, let's go to particletoy. It's possible if I didn't have you walking me through this, I would just never fix this. Okay. Here we make the axes. That's not what we care about. I turned the try count down to 2 because I thought maybe we'd try to solve this simple problem first and then crank it up.
Sounds good. To be fair, it shouldn't matter.
You're totally right. It shouldn't matter. Okay, so we are trying to load the particle mesh into the renderer, right? And what the particle mesh cares about is this thing called a data mesh instance. If you recall, we used to have a thing called a data mesh. I created another one that's similar to that, which is a data mesh instance, which basically describes under the hood what the particle emitter is using as its data. And what you get is the primitive. Again, this is almost always a triangle. Then you get attribute buffers, and these are the non-instance attributes. For our particle shader, this is literally just going to be the position, right, of the vertices. I've changed the format of the data mesh instance so that I'm basically passing maps of an attribute location to some kind of object rather than enumerating them all, because it started to get a little bit verbose.
Okay, yeah, that makes sense.
Yeah. And in fact, I may go back around and make the same conversion here as well. The instance...
Sorry, I was going to say, I wonder if every data mesh becomes a data mesh instance after this anyway. And sometimes there's just one.
That is a really good point, right? Yeah. Like at some point, I think there's going to be a reckoning.
Yeah, like nothing should be rendered uninstanced. And if it is, it can be an instance of one, and that's probably fine.
Yeah,
We seem to have GPU power to spare at
I
least.
think you might be right in that we do want to kind of like, because if you think about it, like this is already or encompassed by this, right? Data mesh instance already with these two properties has basically accounted for everything that was in the old data type. But now we have this new thing called instance attribute buffer config. And then I have this notion of vertices per instance, which will come into play later. These two variables are not the same type, right? This is a mesh buffer, which is just under the hood like a float32 array, right? This, on the other hand, is a buffer config. And a buffer config says, what type of data do I have in this array? How many components per attribute? So in the case of a translation, that is 4 components per attribute. In the case of a mat4, that is 16 components per attribute. And then this is also, then this here basically tells us the number of attribute slots consumed by this particular attribute. And if it's not defined, I just assume it's 1, right? One attribute slot.
That's also very similar to a mesh buffer right now with just one optional attribute on it. So
it is quite similar.
Data type?
This one actually, mesh buffer actually provides the data ahead of time, right? Because it came from like Blender or something like that. Whereas the buffer config, we assume that this data is going to get overwritten frame over frame. So we don't make the caller actually instantiate that array. That actually could be a mistake. Maybe we should just make them instantiated.
Gotcha. But wait, so what type is array data type then? Sorry.
Oh yes, array data type is one of these GL enums.
I see. I see. Gotcha. It's not the buffer. It's okay.
It's not the buffer itself. But we should put a pin in that, right? Because we like, I'll introduce to you a problem that this introduces, that that this causes. Okay, so that's a data mesh instance. You're basically saying I have some things that I know ahead of time, the stuff I made in Blender, or the stuff that I made by hand, and that's not going to change instance over instance. And then I'm telling you my other attributes are going to change instance over instance. I'm not going to create the arrays for you ahead of time because I want you to just do it for me, right? And then we can dive into, like, in the renderer, this is going to get converted into a, what was this? No, it was in GL utils, I think. A render mesh instanced, right? Which is the instance equivalent of the render mesh. And if we look at what the renderer actually is keeping as its internal state, the models were render nodes. Each render node is like a tree of render meshes. The particle meshes, I don't have a hierarchy here. So basically, it's just like one mesh per particle model, so to speak, right? And it's because they're so primitive. If we have a hierarchy for our particles, I think we start to get into a complexity problem. Like, it becomes really, really tricky to deal with. Nice. We could do it, but I just had a hard enough time even getting this far. So, again, I think, like you were thinking, it's possible that these might get merged, right? In a similar way that we're talking about merging other things.
I could see it, yeah. But I look forward to finding out.
Okay. Okay, so how do we actually convert a data mesh instanced into a render mesh instanced, right? Because that's what the load particle mesh is doing, right? Give it a name. Here's the description of the mesh itself. Here's how many of those things we want to allocate for, right? All right, so we're going to go into GL utils, and we're going to go to make render mesh instance. All right, so this is actually looking a little bit similar to this this interface on the renderer. And in fact, all it really is just calling that function, right? It's like, I'm going to basically take the name you gave me and bind it to whatever comes out of this function. So I think all of my problems in the particle toy here come from this function. Like, I'm just doing something wrong, right?
Gotcha. Okay.
Yeah. Anything I should retread on before we go into this function?
No, this seems like the meat and potatoes of it.
Okay. We create a VAO. We bind a VAO. We go through the attribute buffers and we bind them to the VAO. Right. And this is actually all the stuff that we did in make render mesh above. We make a render mesh, we create a VAO, we bind it, and we bind each attribute one by one.
Yep. And I mean, this is what we did top to bottom when we just followed the example on Thursday as well. But much more sort of manual for that one.
You can see here in this code why having it in a loop is a little bit nicer. Like this is a lot of boilerplate, right?
Yeah, and it's bit us before too, so this is great.
Mm-hmm. Yeah. So here we just do it in a loop and we just call it there.
Nice.
So this is where it gets a little bit interesting. Let's go over the instance attributes that are defined in the data mesh instanced and go through those. We create a buffer.
Cool.
And then create numeric array is just this switch that says if it's a byte, give me an int8 array. If it's an unsigned byte, give me a uint8 array. If it's a short, int16. Pretty straightforward, right?
Yeah, seems reasonable.
Yeah, okay. So create numeric array says, okay, give me the array type that is specified in the buffer config. And we have to decide what the capacity of that array is.
Cool. Yeah, and I see the accounting for matrices there, which is nice.
Yeah. So and actually a matrix, we would basically say that the components per attribute is 4.
Oh yeah, but you're accounting for it with multiplying by the attribute
slots. Yeah. So if we had a float 32 array, we would pass in float here, and let's say it's the color, which is 4 float 32s, and we wanted 1,000 instances. We'd want that float 32 array to be 4,000 elements, right?
Yeah,
because every 4 element chunk is a single particle, a single instance, right?
Yeah, if each one gets its own color, yeah, totally.
Yeah. So we take that number of instances, which is 1,000. It'd be 4 components per attribute, and then the number of attribute slots is 1, right? It would probably be undefined, so it would just like fall back onto this 1 here.
Yep.
I think. We take the buffer data that we just got, and we call bind attrib buffer, which is actually the same function that we were using up before. So the fact that we're reusing code here may also be a problem. Like I tried to update this function to account for it, and it may be gnarly enough that it's a problem. And you can see that there's actually a new parameter that goes in here called is per instance. Yeah.
Okay.
Yeah. So, and then, okay, let's just say that, okay, once that's done, what we do is we store a binding between the attribute location and the GL buffer object. And the reason why we need to do that is, you remember in the render when we actually drew this stuff, we needed to overwrite the data, which required us to have a reference to the GL buffer, which is why I'm storing it here.
Gotcha. Okay.
Back when we did regular render meshes, we just didn't care, right? We like created the buffer and we just chucked it, right? Like this function returns the buffer, right? You see that WebGL buffer? But we don't do anything with the return value, right? Because we never have to deal with anything.
Gotcha. Okay. And sorry, I saw the instance attribute buffers. Okay, that's gotcha. So we create that. I assume you return it at the end of this. Cool.
Yeah, it gets basically bound up in this giant data structure, which is a render mesh instanced.
Bingo. Okay, cool.
Okay. Yeah. Sweet. So once we've gone through all of the instance attributes, we clear out the current VAO, we clear out these pointers here, and then we return this whole thing, right? Verts per instance, we just need that for the draw call. So it's a little bit like the primitive as well. Okay, so let's talk about bind attribute buffer. So this may be where the mistake is. So we'll see. Oh, it's funny. I'm not passing in the number of attribute slots, even though it's an option. So maybe I can start with that. Oh.
Nice. Yeah.
That didn't fix anything. I saw it flicker, and I was like, okay.
Reloaded, but yeah.
Yeah.
And just to really like, we're sure we're actually loading this and rendering it in RenderToy, right?
That is a great question. Let's talk about that.
Yeah. Before we like, at least try to go too deep.
Yeah. Particle toy main.
Nice.
We load the mesh.
Okay.
Press animation frame, clear everything out, render the axes. We update the transforms. Transform data just gets. This is actually I left it alone from before.
Cool. Still the silly version. Yeah.
Yeah, it is 16 attributes per instance times the number of transforms.
Yep. 16 floats per instance.
Yes, 16 floats. Yes, sorry. And then we rotate around the z-axis. Then we.
I see render particles called, but that's our old call, right? That's the weird one we wrote. That's not.
Oh no, this is it.
Oh, that's okay. That is what's going on. Great.
Yeah, because the old one was a function, was just code. It was just like straight code that we didn't have a function that did it.
Oh, right. We just left it in here.
Because this is on the renderer.
Totally.
Right. So what we're doing here is xforms are matrices. Xform data is a giant float32 array.
Yep.
Right. I think technically this is the thing that I wanted to avoid when I was talking about the particle system just having these like giant linear arrays of data. JavaScript has the notion of a buffer view or a data view, is it? And a data view, you can basically say, here's my underlying buffer, and here's an offset and a length, and I'm going to get back essentially another float32 array that shares the same underlying memory. So you can basically have two objects that point to the same underlying memory.
That's neat. That feels very useful for what we're doing.
Right, right. So in this, well, we're not doing it here, right? So we basically take our matrices and copy it into the giant linear array, right? After we've applied the rotations to them. And then we actually have to pass in our data into the renderer. So we're going to take all of our colors. This is just it's not a giant array, actually. We only have a couple colors. This is really small, right? And here's our instance color. And then we have the transform data here, right? And then we pass it in as the instance transform attribute. Let's make sure that the shader is doing what we want. Instance color, instance transform. Okay, so it's using the new name scheme. There's been a lot of changes here, so anything could potentially cause the problem, but it looks like that's correct. Right?
Yeah, I'm mostly just surprised that there's no error in the render.
Yeah, well, it's kind of those annoying bugs, right? So then we pass them in and we say that we want to draw two of these things, right?
Cool. Yep, seems reasonable.
One thing I want to look at here. So bind attribute buffer. Coming back to this function, this is where I was saying maybe there's an issue here. This is shared by both our regular render mesh function and our new instance render mesh function.
And our regular renderer is working great.
Yes, our regular one works fine. So the game runs, right? You saw the dog running around. So we make a new buffer. We bind the buffer to the array buffer stage. It's almost like you're staging it to be modified, right? Oh, this is interesting. Does it need to be dynamic draw? So that's one problem, right?
That's a good question. Yeah, we thought that was optional, but I guess if you can do is per instance, that's really easy to fix.
Is that gnarly? That's gnarly.
A little bit.
What do you call that? Is it draw mode? Usage. I mean, I'm just going to copy this out, right?
Yep.
Maybe it was fine. I don't know.
Cool. No, that looks good.
Okay.
Wait, we should put the particle toy back on the left side so we can see it.
Yeah.
Just in case something magically shows up, but it won't.
Yeah. Okay. That is our usage. We populate with the data, right? And in the case of our instance attribute buffers, the data is just an empty array. We just literally created it here. It's not coming from Blender. We didn't like pre-generate the data, so it's pretty much all zeros, right? Going into it. I do some funny conversion because I'm not passing that array data type value in here. So, but you can infer it from the type of the array. Yep. So just looking at this, it's basically the reverse of that other function, right? Like if it's an int8 array, it's a byte. If it's a uint8 array, it's an unsigned byte, so on and so forth. I'm just eyeballing it right now to make sure I didn't make some kind of boneheaded mismatch mistake, but I think it's good.
Yeah, that looks all right.
Yeah. Attribute, location, stride. That is a lot of fucking words jammed together. And I think this is because I basically made this for loop to deal with the matrix. It complicates the code horribly. But let's actually just take a look at what this loop is doing.
Yeah. Well, and the nice thing is, works great for one. We know that much.
Works great for one. Yeah. So, yeah, if you have one attribute, it's just basically running this code straight, right? We take our attribute, we add the slot index onto that, and that's basically the location of the current slot that we're working with. We enable that vertex attribute array, right? So far, so good. And then we configure the pointer for that. And we say it's in this location, it has this many components per attribute. This is the array data type that it's got. This is whether it's normalized or not. We never change that from false. I think we just kind of cargo cult it. These we usually put 0 into, right?
Yeah.
This last one is the offset, I believe.
I forget. Did we have to do this 4 times for the matrix? I thought for the matrix we ran it once and it just sort of knew. All right, I gotta look at last week's code. 1 sec.
Yeah. Let's take a look.
Yeah.
Is that legible?
Yes.
Okay.
It is. Oh no, I'm full of shit. Great.
Yeah. So 2 is basically where we stuck the transform attribute, right, in slot 2.
Yep. No, I totally forgot that this was a that was okay. So you move the code over. Looks great.
Yeah. So I want to make sure that this.
Yeah, 64 is interesting.
Yeah, and then this one is also multiplying by the attribute location stride. So the attribute location stride, what I'm saying there is how many bytes does one slot's worth of attribute take? And so basically I'm saying, give me the byte size of one element of our array. It's a float 32 array, so the byte size of one element is 4 bytes. And we have 4 components per attribute. So it's 16 bytes. That's how much like one attribute slot is occupying, right? So I think that this here, line 187 at least, this last offset is consistent with what we did before.
Yeah.
And then the stride here, this is 16, and then the number of attribute slots that we're consuming is 4. So 16 times 4 is 64. So I think the math roughly lines up here, right?
Yeah, seems like it.
Damn. And I was actually worried that setting this value to a non-zero value would screw up our regular rendering, but it didn't. Because normally we set that to 0, right? We usually set it to 0, which I think is telling the driver to just infer what the stride is. And I'm pretty sure the driver just does this math. Because it has access to all of these things. We're passing it components per attribute. It knows what array element data type it is because we're passing it in here.
Is components per attribute not... Oh, is it 1 for everything now? Not 0?
Sorry, components per attribute?
No, never mind. That's yeah, never mind. I was thinking that was... I thought that was optional. How many slots was taken up? Nope, you're good.
Yeah. So I think that like this is a correct calculation for the stride, even if we're talking about just one attribute,
Yep.
like a single attribute slot, right?
Yeah. Yeah, and
Um,
we continue to have good evidence for that. So
yeah, I guess the stride is basically how many bytes do we move ahead in the array to move to the next attribute value, right?
I sure feel like this code
And then
is
if it's a
fine.
per, and then if it is a per instance attribute, we call vertex attribute divisor of with one, right? Um,
Yep.
and I was a little bit worried about this one here because with the colors, when we had a bunch of different colors, do we ever have a bunch of different colors? Or was it
No,
always just
we
two?
only did two. Because one is just saying for every instance you take one total. I don't really know what is. What is that?
Yeah. Well, this is for the color attribute. We did tries divided by two. And I think we were just debugging, so we might have just been throwing shit at
I
the
think
wall.
one would have been okay there. Yeah.
Yeah. I mean, I guess the question is, does it wrap around, right?
Well, and I think we have good evidence that it did because the particles seem to alternate. We had equal numbers. Well, we didn't count, but we had equal numbers of blue and purple particles. So
Yeah, but I think in that case we had like what? We had 10,000 things. This was the number 5,000. And so what that was saying is that we have to go through 5,000 instances before we go to the next attribute value.
oh, so it might have done 5,000 blue then.
And then
Oh,
moved
okay,
moved
great.
to
Well, that's
magenta.
easy for us to test then. Yeah.
Yeah, exactly. In fact, I could just like check out the old code. We could change this to one, and if it still works, that means that it's wrapping. We just have
Yep.
a wraparound effect, right?
Cool.
Which kind of makes sense.
Yeah,
I don't
I would
know.
expect that. But when we get this working, we can test that too. But I think
Yeah.
since one is hard coded there, we'll find out really fast what color things come out when they are.
And then I added this thing in here, which I think is fine again because it works for the single attribute. It works for the
Yep.
regular rendering.
Because you're not nullifying anything. You're just taking the context off the graphics card.
Yeah. Although what's interesting is for the index buffer, we had this bind index buffer function, and I used to have a bind buffer GL element array buffer null at the very end of this function. When I experimented with that, it actually breaks indexed rendering.
Oh.
And the reason why is that this actually modifies a value on the VAO. It doesn't modify the value on the general renderer state.
Right.
So if you clear that out on the VAO, you get what I'm saying.
Yeah,
right?
but this is I think a different. Well,
It's a different thing. Yeah.
It might be.
So what we do is we actually unbind the VAO first, and then we clear this stuff out
Yeah.
and just say like, okay, now we don't care anymore. Now this call is not going to modify the VAO anymore. Right? Yeah, I think what was happening is I was calling this function inside the bind vertex array, so the VAO was still bound, and that was actually clearing out the index buffer. And so when I actually went to draw, it was saying like I don't have any indices. Yeah.
that makes sense. Okay.
Okay, so we've kind of drilled down to the general structure of what I wrote. We fixed a couple of bugs in there, like dynamic draw versus static draw. Still haven't quite fixed it, but the general idea of it, I think, is coming across,
Yep.
right?
Yep.
Yeah.
And it seems pretty reasonable.
Yeah.
Nothing. Yeah, nothing's screaming out broken here, and
Maybe what we can do is compare this code to what's in
Yeah.
here. Should we start from the top?
yeah, let's do that. Let's see if we missed anything.
Okay. So let's talk about actually creating VAO one more time. So it's pretty close to here. Make render mesh instanced. We create the VAO. We bind the VAO.
Yep.
That happens there. This is regular attributes right here. Position buffer is not instanced. So we call bind attribute buffer on that. We're not going to go into the details because we know it kind of works, I think.
I think so.
Okay.
We're not forgetting to like rebind this VAO before rendering or something, right? Well, we haven't looked at render particle yet, have we? Or have we?
Let's come back to it. Let's go back to it.
Yeah.
We talked about it like the first thing, but
Oh,
it
yeah,
helps
yeah,
to
yeah.
review.
Yeah.
So let's compare that
Sorry,
to
now the whole thing
equivalent.
is in my head. Yeah.
Yeah. So the VAO doesn't have to rebound in particletoy because, well, we do. We bind the VAO because we draw the axes as well. We do switch between different VAOs, right? We bind the VAO here. In this case, we pull the particle mesh out of our internal list of particle meshes based on the name key.
Yep.
And we bind the VAO object that's attached to it.
And it was not throwing any errors, so getting through here.
Yeah. Then we go through each of the buffers we want to update, which in this case is merely the positions, because we knew a priori that the colors weren't changing.
Sorry, just the transforms. Is there a chance that we
yes,
are
the
writing...
transforms.
Well, in this case, are we writing the colors to nothing? Are we not... We're not passing in fresh data to be written to the color buffer?
Right. Let's see. So we are passing in colors.
That gets passed in fresh. Cool.
And I mentioned like let's put a pin in a thing that might be breaking something. Because the way that the data mesh instance structure is defined, the instance attributes you can't pre-populate it with any values.
Right.
Which means that you have to set them at some point. And so I couldn't emulate the old behavior of not setting the colors here because otherwise nothing would have set the colors. They would have been totally zero.
Okay, right? So they're set every time, but like that's fine.
Yeah. Like this is not something we have to worry about right now, but like we could just force the client to pass in the full buffer.
Someday, yeah.
But the thing is that it's error prone, right? Because there could be multiple of these things, and you need to make sure that they all have like the same size, right? The same number of instances, and it feels like it's better to just like say, okay, these particular attributes are instanced. I'm gonna be updating them live at some point, and I want to you figure out the math for me, please. All right. So back to render particles, right? We update the data. So we pull the buffer for the attribute that is being passed in. If it's not defined, then we have some issue. It means that the caller is trying to update an attribute that wasn't defined when we loaded the model in the first place. Loaded the mesh, the particle mesh.
Right.
We call bind buffer for that GL buffer, and we call subdata to actually write the data in there, right? The data comes from what's passed in to this function. And then we call draw arrays instanced, GL triangles, 0. Verts per instance, this was passed in all the way in from the data mesh instanced object because we just needed to know what value to pass in here.
Yep.
This could be like a 2 triangle particle, like that could be like it could be a quad, right? In that case, it would be 6 verts per instance, right? And then the xforms.length is basically just the number of things the number of instances.
Correct.
Right?
Yeah.
So that seems like it lines up pretty nicely. So like, I think what I'm just trying to say is like render particles maybe is okay.
Seems like that's doing the thing too. Yeah.
Okay.
There's no logs in the browser on particletoy. It's not throwing.
Yeah. Should we maybe do command line debugging? Breakpoint debugging.
Yeah, if we can do that, let's hit it.
Okay. Let's see here.
Did that update? Did Chrome like re-render when we did that before? If we like stop on a render step, was it doing a?
I think is
it
a good question. I don't 100% remember.
Okay.
But,
yeah, we'll find out.
Just copying the configuration over here. I think I can kind of debug with multiple windows open, but I'm not gonna. I just want to make sure that like I launch it correctly.
Yeah, totally.
And it's going to launch into a new window, I think. Oh, that's not what I want to do. There we go. Don't care. All right. So if I was to just break into render particles, right?
Yep. I love that it just Did it immediately stop on that? That's great.
Yeah, because it's happening 60 frames a second, right?
This is great. Cool.
So our attribute data is what's being passed in. We have two attributes. 0 are our colors.
Yep, 2 colors, and right now with 2 triangles there should be 16,
it is, yes.
16 per. So that checks out too.
This checks out, right?
Yep, and it's at 7 and 8 as expected. Yeah.
Yeah, and then this does look like transform matrices. You got the 1 in the lower right hand corner, right?
Yep.
Okay, so that looks like it's going well. It's the default thing. We're going to keep stepping. Mesh is defined, and our mesh is what was loaded. This is the thing that we think might be problematic, right?
Got our 2 buffers. Yep.
Am I? No, we are setting the we're setting the uniforms correctly, because clearly the axes are drawing it the way that we expect, and the camera is able to scroll and stuff. So all of those transforms are working correctly. Instance attribute buffers. Yeah, it's just like attribute 7 is the colors. We have the buffer for that. Attribute 8 is the transforms. We have the buffer for that.
Yeah,
right?
it looks
2 instances worth of data can go in there. 3 verts per instance. The VAO that
and I
corresponds.
assume primitive 0 is gl.triangles.
Yeah. What happened here? I don't know where my execution is right now. That was weird. Like I clicked like 3 or 4 times to get into here. Finds the buffer okay. I mean, if it didn't find the buffer, it would be throwing an exception, right? So
yeah.
It's writing the data. Should just do that twice because we had 2 attributes, and then it just calls this mesh.primitive 0, verts per instance is 3, instances should be 2. So
Seems good.
that's a boggle, isn't it? What an old-timey expression. What a boggle. Real humdinger. It's a doozy.
Boy, okay.
Are our numbers weird?
I was gonna say, are we doing something strange? But like, it's the same data as before, right?
It is kind of the same as before. Yeah. Let's take a look at that from before. Oh, I closed the window. I could have just typed it out and it would have been faster. So our initialization was this, right? We're trying to do some range between.
Oh, it still is. Can we do 10,000 triangles real quick? I'm just curious if like anything is gonna show up on the corner of the screen, and maybe.
Oh, you think maybe it's a scale thing?
Maybe we've missed something, or like something got offset in a funny way.
Yeah, totally fair.
Yeah.
And let's not break, right? Where's our rendering window? Yeah. So
cool. Great.
It feels really
smooth.
So I don't know. It actually feels a little jerkier than before.
Okay.
Let's take a look at the paint. I don't actually know how to like read some of this stuff, but take a profile. GPU is not working that hard.
Yeah.
Right?
I mean, I wouldn't know how to tell you what this was doing.
We're dropping a lot of frames. So the frame rate's really shitty right now.
Huh.
Right.
But we're also running in a debug context, so who knows?
Yeah, it's true. It's true. I mean, it actually doesn't look like there's a huge amount. Do I need to select a range? I think I need to. Would have expected to see a little bit more here in the call tree. Right. Actually, the frames are really slow, really fast, actually. So it almost seems like it's not doing anything. Is there some really trivial bug?
Oh, you mean because the frames are really fast? Right. This probably should have slowed it down a little bit.
It is simulating, right? Because we are able to like move the axes around. So the camera is getting updated correctly. Um,
And then 6. Uh, oh, interesting. You flipped the I and J arrays intentionally. Is it just clear that way for you? Ah, the index works better, doesn't it? Well,
it doesn't.
it doesn't change anything.
I think I don't know why I did that. I think it was actually copied from before. Oh, I did flip them. How did that happen?
I don't know, but it doesn't. Wait, actually, doesn't that? We should switch that back. Because we write a bunch of zeros. We write 10,000 zeros, and then we write 10,000 J1s, don't we? I guess. Well,
I don't think it matters.
no, because we're not appending. We're writing to exact positions, so that's convenient.
Yeah, I mean the values inside the loop are exactly
Yep.
the same.
Yep.
Right. So in principle, it shouldn't matter.
No, you're right. I'm so used to appending in order. Gosh.
Yep.
Yeah, there's no triangles hidden anywhere in there.
There's 10,000 transforms. Whoa, how is it capturing over all these things?
Holy shit.
What in this?
But there's ICX forms at 10,000 there as well, yeah. Each of them is
One of these
a
things.
16 element array. Yep.
Looks kind of like a transform, right? And the X and Y offsets are all here. All of this stuff in here is the rotation data. So it seems like it's where we want it to be. What if we go down to here? Actually, let's look at the colors, right? That's another thing that's interesting. Is it really pulling all this stuff into scope? Wow.
Did we like import star from GL Matrix or something? No?
No.
We did import it twice, which I don't know if that fucks it up.
Oh, that's interesting. Yeah. Like who knows what this actually compiles down to in ES build or whatever, right?
There's colors.
Colors.
That looks super reasonable too.
It's pretty good, man.
Yeah. Ah, man. There's no. Can we do anything? Okay, so wait, we at least walked through our code. What about the shader? Is there any way we can actually like debug that?
There's not a great way to debug the shader, but I think I like where you're going with this.
Because I'm no longer convinced that the shader is necessarily doing the thing we want it to do. This seems so straightforward so far.
Where did we implement the particle shader last time? It was called particle, right?
I thought it was called particle. I thought it was shaders/particle.
It could be that the GitHub search just wasn't working very well.
Yeah.
Render shaders. I might have misspelled it.
I don't think you did.
Thanks for the vote of confidence.
Yeah, I blame GitHub fully on that.
Okay, shader position.
Well, I see a problem.
Yes.
This doesn't use the instance. Oh, is that the? Wait, is instance transform everything? That's not translate. Fuck. Okay, never mind.
Actually, you know what? This already reflects changes because I made those changes at the weekend. Why don't I commit this code and see if I roll back to main, what this is going to look like? Oh. Oh, so this is already broken.
Okay.
This is great. This is good, I think. And it's called render toy again. So it means that it means that what broke it happened in a previous commit.
Yeah.
So let's go back in time. Let's just go to this commit here. I think it's just head. There's just one before head.
Mm-hmm. Yep.
And let's not worry about this. All right.
Yeah,
So that's a site that warms the heart.
That looks
right?
familiar. Yep.
Yeah. Okay.
Right. So what's going on in this particle shader now?
Yeah. Okay. So can we do like a
just hit history. Yeah. Oh, sorry. Go back and you want history on the file to get into that commits version of it. No, you gotta click on the one below it.
I do want to see the
Oh,
diff.
you want the okay. Sorry. Perfect.
Yeah. Attribute position, color, instance transform. It got renamed, but I don't think that matters as long as it's attribute number.
Transform is attribute 8 now.
Yeah.
How does it know? Do we need to worry about that here? I guess we were assigning them specifically.
So your question is almost like, does it matter if they're contiguous or not, right?
Well, and does this know? And does this need to know somehow? Because we had that location specificity before.
Right. Okay. So let's try and force the issue.
Yeah. Actually, wait, even better question.
Yeah.
If you just take transform out of GL position, shouldn't some triangles render at like the direct center of our screen?
You're talking about here?
Yeah, if we don't do our translation, shouldn't the position just be like straight up screen space coordinates through the perspective transform?
Yeah, here's another way that we can do what you're going for.
Yeah.
Let me check out main.
Yeah.
And if we're worried about like gaps, why don't we just like make this 1 and 2, right?
Sure. Yeah. See what comes out.
And then
we'll deal with it.
Probably want to we need to do something with these. So let's just 1, 2, 3, 4.
Well, position still 0. Sorry, gotta keep that.
Correct. 0.
Yeah.
1, 2, and this is 2, 3, 4, and 5, right? Which means that normal is 6, 7.
Well, there's
8.
Is there any reason to update this for render toy?
I'm just trying to get particle toy to work.
Totally.
So,
well, I guess I think if position matters, if continuity matters, we just broke everything else. Which is why I was just thinking that like read.
Yeah.
Well,
So
okay.
this still works. I don't think continuity matters.
Probably doesn't matter. Yeah.
Yeah.
Can we go back to particle toy and try just not using the transform that's passed in? Why? It's so weird. It doesn't want to complete this path at all for you.
Oh wait, this is drawing now.
What? Excuse me? Sorry, wait. Are we on main?
We're on main.
And
so
what's our diff? Is it just that? Okay. And if you stash that, it breaks again? Or was main not broken? Now
is
I'm
it possible that we ran out of slots?
How many slots do we get? Oh.
WebGL max attributes.
We didn't cross 32.
I don't think we crossed it yet. Max vertex attribute 16.
We didn't cross 16?
We didn't cross 16. This is the only change.
Can we stash it and make sure that main just wasn't working? Because
Yes, I think that's totally fair.
I'm very skeptical at this point.
Okay.
Okay, great. Sure.
Is that weird or is that weird?
It's pretty weird. So if you save this file again, it'll just start working.
Overwrite. Don't be sassy with me. Yeah.
What?
That is a peculiar
That
mystery.
doesn't make any sense. What the hell? Okay, can we...
Well, yeah, go ahead.
Can we look at the wire solid shader? You also updated that to use the normal names and like we didn't... Nothing... It's really frustrating.
Because Manchester still works, right?
Reload Manchester one more time, but yeah, it totally does, right? Damn it. Damn it, dog.
So, okay. There's two possibilities. One is that there's just something, there's magic numbers going on.
Yep.
Second possibility is we've screwed up the way that we're doing our slot math.
Somewhere else.
Yes, in GL utils, right? We had a bunch of stuff in here and bind attribute buffer that's not right here in this branch. But we screwed it up, which is a high... Is it high probability that maybe we screwed? Well,
why would the numbers
the number
fix
because if it was... oh, wait. Yeah, why would changing the numbers fix it on main is the question.
Yeah.
Is there something about the... Well, it's because on main... we had hard-coded like the number 2 here for the attribute location. I feel like...
Oh. Wait, what?
This is on the main branch. If I go back to
you haven't
the work in
factored
progress
it out yet.
branch,
Okay.
yeah.
Gotcha. But something is using that mapping still, but not this in particular. What?
Yeah, so we're on main and we changed the attribute numbers and it started working.
But only because they were actually hard-coded to actually look for 2. If you'd picked 3, it wouldn't work. We just got really lucky, right?
Oh yes, you're right. You're absolutely right. That's why this branch was broken.
That's why it's broken on main. But that sure screams that we've got the attribute location wrong in our latest branch somehow. Maybe.
Yeah. Okay. So let's actually
let's dig.
I'm gonna undo these.
Yeah.
Oh my. Oh wait. Oh, that was creepy. What did I do? Okay. This is what I want. I am now going to update particletoy so that it uses the 8th attribute. Cool. And this should be fine.
What?
It's missing some colors.
Oh, because colors is probably pointing to the wrong attribute.
7th one, yeah. Yes. So where did we do that? In particletoy. Come on. You can do it. It's this one, right?
Yep, should be
7. Basically, all of these ones should be 7s.
Seems reasonable. Hey, well,
okay.
While you're in here, do you want to turn take out tries and turn that to 1? Line 86. We'll just take away tries over 2.
Oh yes, and we want to just see if it loops. It does not loop.
Shit. All right. Cool.
Well, that's interesting. It should at least draw 2 triangles, right?
You sure think so, huh? And maybe perhaps it is at... Any errors logged for that?
Oh, good question. Oh.
Yes.
Out of range vertices.
Okay.
Now, if we did turn the number of triangles to 2, it should be fine.
It should render 2.
Yeah.
Indeed.
And they're randomly, and you can see one way down there. I can...
Oh, barely, yeah.
Yeah.
Yep, cool. Okay.
Okay, so that's good to know.
Yeah.
So this is good. This implies that we, in our other branch... Actually, it doesn't tell us anything.
No,
I
but
think
we learned
what
how,
happened
we
is
learned how that value works.
we
Yeah.
debugged main for particletoy. We did not debug the new branch, the refactored branch.
So let's go back to that. So we know two things, which is that
Yep.
we should check our attribute locations, which we can just do by hand basically. And we should maybe check our color and matrix values for exactly that. Make sure we don't have like the wrong count in there. Because sorry, was it one or was it instance count?
Sorry, say that one more time.
The that divisor thing that we just changed on tries. It's not components per attributes. It was instant count at one point, right? Instance count. Oh boy.
How do I? Okay. Wow. So 2000 is not going to work for sure.
That definitely will not work right now.
Yeah.
Yeah. That's great.
Wait, why is this not rendering at all? Oh, there we go. Okay. Sorry, can we go back to what you were saying before?
Well, we just learned that if you go over the bounds of one of our instance arrays, it blows up.
Yes.
So can we make sure that that number is also correct after we verify the attribute locations?
So to verify the attribute locations, we're going to go in here. And
which I feel like we also did when you debugged it. So I don't know.
Did we go over the loop?
Well, we saw it spitting out 7s and 8s, which is what we expected.
But we didn't look at the bind attribute buffer for that particular.
Yeah, you're right. Yep.
Yeah.
Cool. So
waiting for the debugger to disconnect. What happened?
Weird.
Oh, this is just for some reason it had something else selected.
Huh. So in my app at work, we have a reminder function that like reminds you to check in once a day.
Okay.
And I just added it, and I had this reminder set at 8 p.m. But as of yesterday, it started going off at 9 p.m. because somebody forgot to store time zones in the database and just put UTC in there, and it was me.
Wait, so you're doing the database side as well?
Oh yeah, I do the whole widget, baby.
Okay, nice. Well, you know what? It's not your fault. It's the legislators' fault.
No, they should have abolished daylight savings time by now and solved this problem for me.
I believe they passed legislation like 2 or 3 years ago saying that they would begin to look into it.
Yeah, I voted for that.
Yeah, I did too. I expected change.
Isn't this... Did you see the thing where Pete Buttigieg is actually allowed to just change this, I think?
Pete Buttigieg is.
It's like the Secretary of Transportation can like change the clocks to make the trains run on time, basically, or something to that effect.
Oh, weird.
Yeah, but
why doesn't he just do it?
I don't know, because he's not actually that great.
Yeah, he's not that great. All right, for another time.
Yeah. I just waited for some politics here.
35,048. That is our.
That's our frame count right now.
No, that is what dynamic draw means, I think.
Oh, sure. Yeah, why not?
Ops per instance, yes. I bet that static draw is 35,047. All right. So what we passed in here, we should have 4 attributes. Oh, come on, don't be undefined. Give me a break, debugger. You can do this. It's not quite good at.
But it is undefined.
TypeScript.
No, is that not correct?
Oh wait.
So this is for color.
Oh yes, this is for color. Okay,
but,
got it.
But we need that to... Oh no, because it goes to 1. Okay, yeah. Never mind.
Seems it's 1.
Okay.
Let's just step through the color.
Yeah, totally. Let's get our actual attributes.
Seems it's 1. Great. The data type is 5126, which is float. I kind of have that memorized by now.
Awful that you have that stuck in your head.
The stride should be. It's weird how it chunks up the.
Yeah.
I think it's probably because there's something going on in the transpilation.
Well, you just entered a new closure, so it gave you a new closure scope.
Am I in a new closure?
Yeah, it gave you I. I is your closure around the for loop.
I see. Okay, yeah. So I'm in a new block.
Yeah.
Right. Okay. The stride is 16 for colors.
4 bytes times 4. Yep.
All right, starting to be a little suspicious about this. Vertex attribute pointer. I don't know why I'm checking this. It works for the single values elsewhere, right?
It works for single values. I think we've got the.
The math is right.
I think the math is right. The location might be off, and that's.
Okay. The location should be 7.
It sure looks like it.
Slot location is 7. Components per attribute is 4. Array data type is 5126. This is 1 times 16.
Mm-hmm.
This is 0 times 16.
Seems fine.
And it is per instance. We're going to need to update this.
Yeah, that's going to be...
If a particular attribute doesn't eat, like... Well, and the thing is like, maybe we will never do this because probably we'll have one color
I was thinking
slot for every single particle.
I was thinking, well, but if we generate 1,000 particles, I mean, our previous emitter only did like 5.
Okay, yeah, I mean, it's really kind of up to like what we want to do. We could have 1,000 different colors for 1,000 different particles, right? And that's what this would facilitate.
Mm-hmm.
Okay. And that's done.
Yep.
Wunderbar. Okay, next one. This should be the matrix, right? In our buffer data, it's only 32 objects.
No, that's correct, though. That's 2 16 float matrices.
You're correct. It is right. Okay. Whew. We're a little bit over time, but we're going to just do a little bit of minimal investigation here.
This is quite possibly the most debuggy stream we've done.
Yes. At least it's visual, right?
Yeah.
The slot location is 8.
Seems right.
And attribute slots is 4. I think this is correct. Per instance is true. The slot location is 8.
And then we expect to see this wrap around and do 9, 10, 11.
9.
Sure.
Yeah. Is there something where I'm like not using the iterated value of a variable and using its like initial value, right? Like,
yeah,
that's one potential thing is I could be using attribute lock here, right? That's not what's happening right now, but like that's an example of the type of bug that I'm talking about.
Yeah, and we don't need to like rebind. We don't need to rebind the array for every instance of this loop or the buffer because it's the same.
We didn't do it in the other the old code.
No, because you bind for the matrix buffer and then we add 4 attributes into it.
Correct.
Weird.
And they all point into basically different windows.
Different windows, yeah.
Of the same buffer, right?
Oh, what the heck?
Okay, well, we have a mystery on our hands that we need to solve, hopefully over the next couple of
we
evenings.
should solve this over the weekend before Monday's stream for sure.
Before Thursday's stream.
Wow, what day is it? Who even knows? We should solve this before Thursday.
I've actually, you made me scared for a second there. I was like, is it Thursday? What is time?
I mean, it might as well be. Interesting. Okay. I feel like we're really close. I had one other thought on the tip of my tongue. No, lost it. Okay.
It's not happening.
Maybe just... I was going to say maybe the way we're associating attribute locations into the shader program, but like it works for the normal one. I don't believe it. I just don't.
And it works on
main
if we update particletoy, right? If like particletoy we were using, if we actually used the enum value on main,
right,
then particletoy would be fine.
Mm-hmm. Yeah. Damn. You want to try one last dumb thing?
I absolutely do.
Yeah,
yes.
I knew that'd get you. Can we switch to the enum and put color and matrix in 1 and 2 again?
Oh yeah, I'd love to.
Yeah. Because we didn't
2, 3, 4, 5.
Yeah.
Right. 6, 7, 8.
And to be fair, these three don't matter.
They don't, but I'm just gonna try leave nothing to chance here.
Yeah,
right?
Totally.
Okay, and I think we can just reload it.
Just run it. Yeah.
Yeah, it didn't work.
Cool. Okay.
Any error messages? Nothing. Gosh,
I expected as much because the last time we did that, the game still worked.
Yeah, and the game still works.
Game still works. Damn it! Damn you, game.
Did you recompile? Yes.
Yeah. No, it's flashing. I see it doing the thing.
Okay.
Well, I think we learned something tonight.
I don't know what it is
but I'm not quite sure what yet.
Yeah.
I think we learned that instance rendering is a huge pain in the butt, which is what you said at the start of the stream.
Yeah, this is a big diff. So I cordially invite you to take a peek.
Let's you already committed this whip to the branch. Do you want to fix main? Can we put the attributes
correctly
I will
fix
in main?
main, yes. Really quick.
Yeah, you don't need that. We don't need to commit that. Because then at least, then we'll have a working
main
between the two.
Yeah. The main fix was what?
It's
just here.
Yeah, it's 7. Colors become 7. That becomes 8.
This should be shader attrib dot instance transform.
Mm-hmm. Oh, I love it. Yeah.
And then this is all instance color.
Yep.
And it should just be peachy, which it is.
Still peachy. Cool. That's great.
This is really too small to work in. What am I doing?
And yet you were doing a great job. So
thank you. Session 78.
Womp
womp womp.
We haven't really had a womp womp in a while. So
I don't know. The real prize was actually you understanding this stuff, because 2 heads is better than 1.
Mm-hmm. The real game is just the friends we made along the way.
Yeah, exactly. Oh, we're zooming through our particles. Oh,
I mean,
if this was smooth, it'd be really cool.
Oh, you just got to switch to Safari.
Really? Really?
And turn on the experimental support.
I think it's on.
Oh, cool. Yeah.
I think it's on. Oh yeah, that's quite a bit smoother.
It's a lot better.
Yes.
But you can't drag and rotate for some reason.
I really ought to fix that. But this is very cool. It's a very cool feeling.
It's pretty cool.
This is our whole game. This is it.
I mean, I'm ready to make a space simulation.
Okay.
Any day of the week.
Yep. Space triangles.
Space triangles. It looks really cool.
Yep.
Sick, dude. All right. Well, thanks for tuning into some debugging, everybody.
All right.
See you later.
See you on Thursday.